So you see, today we are going to solve example number 2. And this example is also related to rigid body equilibrium, but I am going to solve this problem by applying moment on the axis. So you see, in this example, we have to find the reactions, normal reactions at the fields D, E, and F. So these are our normal reactions. You see, we are given weight at point A, which is about 45,000 pounds, and at weight at point B is about 8,000 pounds, and weight at point C is about 6,000 pounds. And you see, these weights are acting vertically downward. So let apply moment about x-axis. So you see, when we apply moment about x-axis, so we get 8,000 pounds, which is basically acting at point B. And you see it has a parallel distance of about 6 feet. And we have reaction force acting at wheel E. And it has a parallel distance of 14 feet. And you see it is negative, you see, because it is moving clockwise direction with respect to point, with respect to x-axis. You see we have negative 6,000 pound force, which is basically the weight acting at point C, and it has a distance of 8 feet. And you see it is also moving in clockwise direction with respect to x-axis. So it is negative. And you see plus we have the reaction force at point E, and it has a perpendicular distance of about 14 feet. So through this I get the equation which says that negative reaction force at wheel D plus reaction force at wheel E is equal to 0. So you see, we cannot find the reaction force using this equation. So let's apply moment about y-axis. So through this, I get 8,000 pounds with a perpendicular distance of 4. You see, it is acting at point B. You see, I have 45,000 pounds, which is acting at point A, and it has a velocity of about 7 feet. Plus, I have 6,000 pounds, which is acting at point C, and I have vanished about 4 feet. Negative, I have a reaction uh, for that is acting at wheel F, which has a perpendicular distance of about 27 feet. And you see basically the RF is moving clockwise direction with respect to y-axis, so it is negative. So through this, I get the reaction force which is acting at wheel F, which is about 13740.74 pounds. So let apply what about z-axis. So you see this is the axis, which is reaction force at D plus reaction force at E plus reaction force at F. Negative, I have 8,000 pound weight. Negative, I have 6,000 pound weight. Negative, I have 45,000 pound weight. So you see through this, I get an equation which says that the reaction force at D plus reaction force at E is equal to 45259.2. So when I solve these two equations, I get reaction force at E and the reaction force which is acting at the wheel D. So which is about 22.6 lb, or you see 22,629.6 lb. You see that the reaction forces at the wheel E and at the wheel D are same. See, because these two reactions lie at CY axis.